Hey guys, this is CHEMPLIFIED and today we will talk about inductive effect. In this video we will only take inductive effect as topic. In the next video we will go for mesomeric effect as well as electromeric effect. So let's start with the definition of inductive effect. Inductive effect can be defined as the inductive effect or I effect refers to the polarity produced in a molecule as a result of higher electronegativity of one atom compared to another atom in a molecule. Now there are two terms that you should consider. First is polarity and second one is electronegativity. We will look at them one by one. What is the meaning of polarity? Polarity means being polar. Being polar means having positive and negative charge separated by a distance. Alright, remember this statement. Positive and negative charge separated by some distance is known as a pole, or this effect is known as creation of polarity or simply polarity. Alright, the second term was electronegativity. Electronegativity is defined as the ability of an atom to attract the shared pair of electron towards itself in a molecule. Let us consider an example to understand this. Let there be a molecule like this. It's a simple molecule. Let's move it a little bit. Now, in this particular molecule, there is no electronegativity, there is no inductive effect between carbon and hydrogen. Between carbon and hydrogen, inductive effect is 0. We also take it as standard, right? But in case of carbon and chlorine, there is a large electronegativity difference. Electronegativity of chlorine is much greater than that of carbon, which means the shared pair of electron will shift more towards chlorine. So the molecule will kind of look like this, right? The electrons will shift towards chlorine. Now since the electron shifted towards chlorine, not completely, partially, there will be a partial negative charge on the chlorine atom. And since electron shifted away from carbon, there will be a partial positive charge created on the carbon atom. This is your creation of poles or polarity because of high electronegativity of one atom. Now let's look at the definition once again and we will understand how it works. The inductive effect refers to the polarity. Polarity means creation of charges, creation of positive and negative charge on two different atoms produced in a molecule as a result of higher electronegativity of one atom compared to another atom in a molecule. That's what we see in the following example. Creation of negative and positive charge because of higher electronegativity of chlorine as compared to that of carbon, right? Now let's move. Now we will talk about types of inductive effect. So there are two types of inductive effect. Number one is minus I effect. Number two is plus I effect. There are only two. And the third one is zero I effect, like in case of carbon and hydrogen bond. But we will mainly study minus I effect and plus I effect. Alright. Minus I effect. First we will look at minus I effect. Those atoms or groups which have the ability to attract the shared pair of electron towards itself will show minus I effect. Or you can also say those groups which have higher electronegativity and can attract a shared pair of electron towards itself will show minus I effect. Examples of such groups are NO2, fluorine, chlorine, bromine, iodine, all the halogens. Fluorine, chlorine, bromine, iodine, hydroxyl group, and benzene ring or phenyl group C6H5. These all will show minus I effect. Alright. You have to remember all these groups. If they are present in a molecule, they will show minus I effect. Now let's move to the plus I effect. So for plus I effect, those atoms or groups which have the ability to release electron towards the other atom will show plus I effect. And groups which can release electron towards other atom are, these are generally methyl groups. This is your tertiary alkyl, this is secondary, this is primary, and this is simple alkyl group. Now if you give them number 1, 2, 3, 4, the highest plus I effect will be shown by 1, then 2, then 3, and then 4. That is, tertiary alkyl group will show the highest plus I effect, then secondary alkyl group, then primary alkyl group, right? This will be the sequence of extent to which they will release electron or they will show plus I effect. Last but not least, more to know about inductive effect. So there are a few things that you should know about inductive effect. An inductive effect is not confined to polarization of one bond. This is transmitted along the chain. For example, this is a carbon chain, and at the end there is chlorine atom. So it will attract the electrons of first carbon. This will create a small positive charge, right? This is delta negative. This will create a positive charge, and this positive charge will attract the electron towards this carbon. This will again create a small positive charge. This will attract the electron towards the next carbon. Like this, this inductive effect is transferred along the chain, and the overall charge is equal. Delta positive is equal to delta negative, right? Remember this. Now another point is, inductive effect is a permanent effect. Yes, inductive effect is a permanent effect. The creation of charge will not change unless and until there is some external effect that will neutralize this change. There is one more point, third point. Inductive effect only involves sigma bond. Remember this point. Pi bond is not involved in inductive effect. Inductive effect only involves sigma bond electrons. Only sigma bond electrons will help you to see whether there is inductive effect going on or not. So this will be it for inductive effect. In the next, we will go for the mesomeric effect. Thank you for watching.